Hello everyone, first of all thank you for being here in my YouTube channel. Please subscribe our channel for more number of electrical videos. So let's talk about average value, RMS value and form factor, peak factor of sinusoidally varying voltage and current. Let's move on to the topic, that is average value. I draw one waveform over here. There is a sine wave from here to here. Okay, here there is a I1. This is I, okay. I is equal to Im sin omega t. We got the equation from the derivation of generation of AC voltage. I2, this is I3, so on up to In. Okay, I'll take In. How to calculate? This is I. How to calculate average value of this waveform? I is equal to I1 plus I2 plus I3 divided by so on up to In divided by N. Right? This is a basic formula for to calculate average value. So average value, arithmetic sum of all the alternating quantities over one cycle is called as average value. Our average value is equal to area under one cycle divided by base. So 2 pi is the base, right? Here to here 2 pi is the base. Here this one is pi, this is 2 pi. 2 pi is the base. So 0 to 2 pi V d omega t. So after integrating, after taking the average value, so this positive is equal to negative. Finally we get 0 answer. I average is equal to 0. So that's why I have taken only one half cycle, this half cycle, okay. So the base is pi, right? Okay, only one half cycle I have taken, and then base is pi, area under one half cycle. So 0 to pi I d omega t. So the equation is like this: I average is equal to area under one half cycle is 0 to pi I d omega t, and then base is pi. What about I average? I average is equal to 0 to pi. I'll substitute I am sin omega t d omega t, right? Divided by pi. I'll take pi this one, okay? So I'll take I am by pi outside. I am by pi is equal into 0 to pi sin omega t d omega t. Okay, d omega t is there. So after integration, I am by pi sin omega t is minus cos omega t 0 to pi. Finally, you will get the equation. So I am by pi minus cos pi minus of minus plus upper limit minus lower limit cos 0, you will get plus 1 minus cos pi plus 1, here cos 0 plus 1. So we will get I average is equal to 1 plus 1 is 2, I am by pi as it is into 2. So we got the equation as I average is equal to 2 I m by pi. Similarly for voltage 2 Vm by pi. Okay, this is a derivation of average value. So this is average value. Okay, 2 Im by pi in the sense 63.7% of maximum value. 63.7% of maximum value will get I average value. Just to keep it in your mind. So here 63.7% of maximum value. Next, there is a RMS value of alternating quantities, also called as root mean square value of alternating quantities. So there is a diagram present over here. There is a resistance present here and then here. The same resistance, just to assume the supply is different. Here AC, but here DC over here. So if you pass electricity DC or AC, same amount of heat is produced in the resistance in a given time is called as RMS value, right? And the formula is like this: root mean square value is square root of area under squared curve divided by base. So VRMS is equal to, I have taken full cycle, root of 1 by 2 pi 0 to 2 pi V square d omega t. What I have taken? So I'll derive the equation now. So there is a sine wave present over here. There is a sine wave. Okay, just one sine wave I have taken. One sine wave. This time taken is omega t. So angular frequency. This is I is equal to Im sin omega t. So if you square this one, you'll get like this, right? Waveform. So this one I square is equal to Im square sin square omega t. So don't confuse, we'll get positive only, because if you square this sine wave, we'll get positive waveform. So according to the statement and then wave equation, I RMS is equal to here pi, and then this one is 2 pi. Okay, this is pi and then 2 pi. 0. This is I and then I square, right? So according to this one formula, IRMS is equal to square root of area under squared curve, that is 0 to pi I square d omega t divided by pi, right? I substitute I is equal to Im sin omega t. So right, so root of 0 to pi uh, Im square sin square omega t d omega t divided by pi. I'll take outside this Im square and pi. Root will be there as it is. Root means square value, right? So that's why. So Im square by pi is into 0 to pi sin square omega t d omega t. So next I'll be converting into sin square into 1 minus cos 2 omega t by 2. So I'll take like this. There is a waveform as it is. Okay. Im square by pi. Okay. Im square by pi. 0 to pi 1 minus cos 2 omega t by 2 d omega t. Right. So similarly, Im square by, I'll take 2 outside here, 2 pi integration of 0 to pi will be there. So 1 minus cos 2 omega t d omega t. So just to integrate now. So as it is Im square by 2 pi. Okay, Im square by 2 pi. So one integration of 1 is omega t with respect to d omega t is there. This one is cos 2 omega t sin 2 omega t divided by cos is sin, right? So divided by 2, 0 to pi. See, I'll be giving one clue. So if you submit the limit, pi r 0, sin pi is sin 2 pi is 0, sin 0 also 0, right? So you'll be getting only omega t. After applying the limit, Im square by 2 pi, you will get omega t pi minus 0, pi minus 0 and minus sin 2 pi minus sin 2 0 by so this becomes 0, right? 0, and only we'll get this part. Okay, so finally we'll get Im square by 2 pi will be there. So finally we'll get IRMS is equal to just root cancel, pi get cancel. So Im by root 2. Similarly, VRMS is equal to Vm by root 2. This is a final derivation, right? So Vm by root in the sense 0.707 Vm or 0.707 Im. That means 70.7 percentage of Im. Okay, IRMS, right? So this is the equation. Next we'll see once again. So there is a RMS value of central current. So essentially they have taken this one is Im sin omega t after integration. So Im square sin square omega t. So you'll get 0.707. I'll tell you how exactly IRMS. This is a maximum value. So practically we can say this is IRMS value. 70% in the sense here we will get this one. So this is DC. Okay. See 70% of Im. So practically you can say all the meters, whatever the meters we are using in the laboratory, that meter shows always RMS value. Keep it in your mind. This is the RMS value of alternating bodies. Next there is a form factor. It's a ratio of RMS value to the average value. This is a formula. Just you substitute the values. See here 0.707 Im divided by 0.637 Im. That is this is RMS value. This is average value. We got 1.11 as a form factor throughout your engineering life for sine wave. Okay, sine wave. Next there is a peak factor. It's a ratio of maximum value by RMS value. That's a Im divided by 0.707 Im. So that is 1.414 for sine wave. Okay. Next, I'll discuss RMS value of alternating quantities because the definition itself shows if you pass DC or AC, same amount of heat is produced in a particular time. H is equal to I square RT is a Joule's equation, general equation. So for AC now, so I'll be taking H heat is equal to, so I'll be taking 0 to T as a time limit, okay? Time, I mean limits. So I is equal to what? Im square sin square omega T dt. So see here, there is a 0 to T, Im square will be there, Im square and R I'll take outside, Im square R. So sin square omega T dt 0 to T will be there. So if you integrate sin square omega dt, d omega T, okay, d omega T. So you'll get Im square R same as it is, you will get T by 2, right? This part becomes T by 2 sin square omega T after integrating. So this is AC. Go to AC. What about DC now? Now DC, HDC. So I square, IRMS square, okay? There is no this one maximum value. I mean that is RMS value. IRMS square RT as it is. 0 to T I considered. So because limit for AC here also same T will be there, 0 to T will be there. You equate these two equation. So I M square R T by 2, this one AC component is equal to DC component IRMS square R T. This T cancel, R get cancel. So IRMS is equal to I M by root 2 is the equation. Okay, this is another method to solve the equation.